So here, as you can see, is a triangle in flat space, right, on the flat surface of the table. And one familiar fact from geometry, just on flat space, about triangles, is that if we were to measure the angle here, and the angle here, and the angle here, and add them up, then we would get 180 degrees. So that's something that we know about triangles on flat space, that the internal angles, the three internal angles, add up to 180 degrees. Okay, so by now we've learned to expect that things are going to be different on the sphere, so in this case it's not an exception. So let's see what can happen on the sphere. All right. So remember before, we've already agreed that we know what it means to be a straight line on a sphere. Right? It means that it has to be something like a longitude line. Okay? It doesn't have to go through the North and South Pole, but it has to be the path of shortest distance. Okay? So let's draw a triangle on a sphere. So what does that mean? It has to be a shape with three sides, each side of which has to be a straight line. Okay, so here we go. So let's draw a simple one. So let's start at the North Pole, come down, and remember we have to use a longitude line because we agreed on that before. So I'm going to come down on a longitude line. This is all one straight line. Okay, and now, boom, I've bumped into the equator. Okay, now the equator, if you think about it, is itself a longitude line, except it's connecting not the North and South Pole, but 2 points opposite each other on the equator. But in any event, the equator is a shortest line. It is a straight line. So I'm allowed to traverse along there. So let's traverse along the equator now. Ready? Like so. That's my second straight line on a triangle. Okay, so you see it? So one line, that's a straight line, that's one side of my triangle, and now we're following the equator for another side of the triangle. And now, remember, my third line also has to be a straight line, so I'm going to pick a longitude line again, because we know those are straight lines. So let's pick this one and follow along all the way back up to the North Pole. There we go. All right, see that? That's my red triangle on the globe, on the sphere. Okay, now let's think. Okay, this triangle, it turns out, is going to have the angles add up to more than 180 degrees. And the reason is, if you think about it, what's this angle right there? This straight line goes straight north. It's a longitude line. This line goes straight east-west. It's the equator line. So, if you think about it, if I have one line going straight north and one line going straight east-west, the angle between them should be 90 degrees. This is a perpendicular meeting. That's perpendicular right there. But hang on a second. This one's the same way. This is an equator line, and this is a longitude line. This is a straight east-west. This is a straight north-south. This is also 90 degrees. So, already, with only two of the angles, we have 90 plus 90 is 180. But hang on a second, we still have one more angle left. That's this one, right at the North Pole. I don't know, maybe it's about 60 degrees. So that means that this is going to add up, if this was 60, then this will be add up to 90 plus 90 is 180 plus 60 is 240 degrees. So we've just drawn, I just drew it at random, but we just drew a triangle whose internal angles sum up to more than 180 degrees, which is something, again, that we're absolutely not going to see on the flat surface. So then, of course, you can ask yourself, well, what kind of triangles can I find on the sphere? So we just found one which had, let's just say, for the sake of argument, that it was 240 degrees. So can you find something that's more, less? Can you find a triangle that has 220 degrees, or just 200 or 190? Can you find something that has a lot more? Can you find a triangle on the sphere which has the internal angle sum to 290 degrees? or a 320. What's possible and what's not?